Welcome my future champions. Today I will teach you what do you mean by refractive index. Okay, so the refractive index of a medium tells us how many times slower. Listen to me carefully. How many times slower light travels in that medium compared to vacuum. It means in compared to vacuum in a medium, how many times the light is slower. Okay, light travels slower. So it is the formula for refractive index mu is equal to c upon v, where c is the speed of light in vacuum and v is the speed of light in a medium. Medium like air, water, glass, diamond, alcohol, honey, etc. etc. Okay. From here we can have the value of v which is equal to c upon mu. Okay. For air, value of mu is 1. So from this formula, v is equal to c upon mu, value of c this mu 1, and we get the value this. Now we proceed. For water, value of mu is 1.33. Okay, so we will see upon mu c, and the value of mu is here. We put this value and we get the value this. This value is less than this value. You can see this value is less than this value. Now again, for glass, the value of refractive index is 1.5. We put this value here and we get the value 2. This value is again less than this value. Fine. Now for diamond, value of mu is 2.42. We put the value here and we get the value 1.23. It means this value is less than 2. So as the refractive index increases, the speed of light decreases. You can see here, as the refractive index increases, although you can see from this formula, mu is proportional to 1 upon v, right? Mu increases, v decreases, obvious. As the value of mu increased, the value of v decreased. What do you mean by this concept? This concept tells us that in compared to vacuum, how many times slower the speed of light became. Okay, but here one more case you have to know, that is about optical density. Okay, water is much dense than air, glass is much dense than water, and again diamond is much dense than glass, right? But this is about optical density, not mass density. Although the mass density is greater in these two cases, the mass density is higher for water. In these two cases, the mass density is higher for glass, and in these two cases, the mass density of diamond is higher. Yeah, we know, it is obvious, but the real fact is about optical density. Okay, refractive index depends upon optical density, not mass density. How? You can see here. For kerosene or paraffin oil, the value of mu is 1.44, and for water, the value of mu is 1.33. You can see the mass density of water. Again, listen to me carefully. The mass density of water is greater than paraffin oil, but the optical density of paraffin oil is greater than the optical density of water. Okay, and that's why the speed of light is less in paraffin oil and higher in water. In compared to these two objects or oils or liquids, in compared to these two liquids, the value of speed of light is greater in water and slower in paraffin oil because of its refractive indices. Okay, optical density increases, then speed of light decreases. So here we observed refractive index is just shows us, it just tells us that how much times slower the speed of light in compared to vacuum. Okay, and when optical density increases, speed of light decreases. Okay, here is the case of optical density, not mass density. You should you should know about optical density, not mass density. Okay, so always you consider mass density, not about, instead you should consider optical density. Okay, to calculate the refractive index or refractive indices. Okay, thank you.